Did I miss anything?
All right, thanks.
You got your camera on? No.
All right, well, I have 1 o'clock, so good afternoon and welcome everyone to the May edition of the AFAA New England webinar series. We have the pleasure of having Carson Cook and Eric Camille from Jensen Hughes as our guest speakers today. As we get started here, I'd like to thank our sponsors, Fire Command Systems, J&M Brown Company, Mammoth Fire Alarms, Urel Service Company, Siemens Smart Infrastructure, Space Age Electronics, and TC Life Safety. Today's session will be recorded, so if you need to drop off, you can view it on our website as well as our past sessions that are posted there as well. We've got a lot of great content today, so we're going to get right to it. Carson and Eric, please take it away.
All right, thanks, Jerry. I appreciate that. Can everybody hear me okay?
Yes.
Yes, sir.
And then let me share my screen here. Let me know.
So you'll connect the
Carson, that coming through okay? Okay.
We are
great.
seeing it.
Awesome. All right, thanks, Jerry. Yeah, so to the group here. So Carson and I are going to talk to you guys about fire resistance rating requirements and how they apply to fire alarm, system equipment and circuits in buildings for fire alarm systems. Quickly here, just a bio for Carson and myself. We both have over 10 years of experience in the fire protection engineering field. Both have our master's and bachelor's engineering degrees from Worcester Polytech, which is not that far away from in the New England area. And we're both senior fire protection engineers with Jensen Hughes. I'm sure we've worked with a bunch of you that are on the call. Just a quick overview of Jensen Hughes. I won't spend too much time here, but just quick overview. So we have 90 plus offices worldwide, over 1,400 engineering employees, and mostly what we do is fire and building safety consulting. That includes fire alarm consulting, commissioning, mass notification, fields like that. We also do a bunch of security and emergency management topics like NFPA 241 or even emergency management plans for oil and gas facilities around the U.S. and around the world. Some of the key service offerings that we have in the Northeast, obviously fire and life safety systems design and commissioning. We also do a fair amount of fire and egress modeling, mass notification systems. We do third-party review on projects for AHJs and just on the owner's behalf a lot of times. General building code consulting, and a whole host of other things, including accessibility and some security assessments and security system design as well. Without further ado, we'll just go through the agenda for today. I'm going to start off, and then Carson's going to hand it off to him, and he's kind of going to go through some examples of where the requirements that I'm going to describe, where those apply in buildings. So we'll start off with just the applicable codes and standards, and then a summary of the requirements that are found within those documents. Then I'll hand it over to Carson, and he'll kind of go through a couple different things. The first topic will be the design requirements, and then the second topic that Carson will talk about will be on the installation side of things. So how do you actually implement these requirements in the field? And then we'll kind of close things up with the Q&A section. With that said, we want to keep this as interactive as possible, so you can drop some questions in the chat and we'll try to answer things on the fly. If it's too large of a topic or we'll go down a rabbit hole answering it, we'll wait to the end and we can answer all questions and circle back on any questions at the very end. All right, so the first section here, so applicable codes and standards. Basically, the majority of these requirements that I'm going to talk about are in the building code and NFPA 72. I'm sure everybody is familiar with these, but we have some references in here to different code sections, and those are taken from the 2015 edition of the building code and then the 2013 edition of NFPA 72. I believe those are the additions that are most commonly adopted for the New England area. So the most common applications for fire resistance rated, control equipment on the fire alarm side, as well as circuits. These come into play when we have specific fire alarm system features such as partial evacuation and/or relocation. So those include high rises, healthcare occupancies where you're not evacuating the entire building, or when you have some horizontal exiting arrangements where there's a horizontal exit on a floor in a larger building. It's important to note that a standard building is not going to have these requirements. It's really a special application when you're either in high-rise healthcare or other special building design that has a partial or selective evacuation means. The second topic here, where you would see fire resistance rated requirements regards to mass notification systems. So this is if the risk analysis that's required when you do mass notification system design. If the risk analysis determines that survivability is required for your fire alarm circuits or your mass notification circuits, then you would have to implement them. That's not a clear-cut requirement that anytime you have mass notification, you're required to have survivable circuits or 2-hour rated circuits. It's really on a case-by-case basis, but oftentimes you do see this implemented in the design requirements of mass notification systems. Another big piece is smoke control systems. So stair pressurization and elevator pressurization are the two most common. General smoke control systems, so if you just have, a theater, right? If you have a theater exhaust system, that's not necessarily going to require survivable circuits or 2-hour circuits. However, if you have a stair pressurization system, because that stair is essential for egressing the building, there's a heightened level of requirements associated with that stair. Same thing with elevator pressurization. So if the fire alarm system is controlling these stair pressurization systems or these elevator pressurization systems, 2-hour requirements or survivable requirements are going to be applicable to those specific smoke control systems. And then the final topic here is, emergency two-way communication systems. So that applies to firefighter telephone systems, two-way radio communication systems. So that would be your bidirectional amplifiers. And then, a couple of others here are elevator lobby emergency communication systems. So those are just.
Eric, we lost the presentation.
It looks like somebody just took over.
All right, sorry about that. Let's see.
Yep. Yep, you're back.
Yep. Got it back? Okay, great. So the last topic there was emergency two-way communication systems. So that's, like I said, firefighter telephone systems, your bidirectional amplifier systems, your circuitry, regarding those, as well as area of refuge communication systems if there are areas of refuge in the building, as well as elevator lobby, just the regular two-way phone communication systems that are required for elevator lobbies. So where does this kind of fit into where are the code requirements located for some of those systems? So NFPA 72, this can be found in section 12.4, kind of defines survivability. I think a lot of you probably are familiar with this, but we'll go over it fairly briefly here. The definition of survivability is the ability of any conductor, optic fiber, radio carrier, or other means of transmitting system information to remain operational during fire conditions, right? So basically what that's saying is if there's a fire in the building, you want to make sure that your system wiring is able to survive for a specific amount of time so that system operates when there is a fire in the building, right? And usually those 2-hour requirements, when we get into level 2 and level 3 survivability, that's basically to ensure that that system is going to survive in a fire event for at least 2 hours. And, the evacuation notification systems will be operating, and it allows enough people to, evacuate the building and the first responders to, use the systems when they respond to take care of an emergency. So, NFPA 72 defines this in 3 different levels: level 0, level 1, level 2, and level 3. Level 0 is pretty self-explanatory, where it's, there's no specific requirements or no design features that make the system survivable or protected against fire. Level 1 is really nothing other than it's usually pathways in buildings that are fully sprinklered, so that sprinkler protection provides some sort of level of survivability that's more than level 0. And then once you get into levels 2 and level 3, those are requirements for 2-hour circuits. So Carson will go over what some of those options are that you can implement level 2 and level 3. Really the difference between level 3 and level 2 is that level 3 is a fully sprinklered building and it has 2-hour requirements on the wiring and circuitry. So that's within 72, and you'll see that referenced many times when you're going through the different requirements. So we talked about different scenarios where survivable circuits are required or where 2-hour circuits are required. The first one being, in building fire, voice alarm communication systems, doing partial evac or relocation. So in this example, the figure on the right there shows a high-rise. Everybody knows the high-rise sequence of events where you have the alarm on the floor of incident, but you evacuate, the alarm floor, the floor above, and the floor below, and the remainder of the building remains, in place. So you're only evacuating 3 out of the 13 floors in this specific example. For this example, level 2 or level 3 survivability is required, and that's within NFPA 72, like I talked about before. A lot of these come out of Chapter 24, and the references are here on the screen of NFPA 72. So this is all laid out there, but basically what it's telling you is that your notification circuits and your other fire alarm circuits that are essential for notifying or activating the notification of the fire alarm system need to be protected as they transition or move between notification zones. I'm going to pause here because I think I lost the screen again.
Somehow somebody keeps taking control.
All right. Let me know. Is that back? Can everybody see that?
Yep.
Yeah, you got it, Eric.
Okay. Sounds good. All right. So as I was saying, for this example, the code is going to require that the circuits that are essential for notification, be protected as they transfer or pass through other evacuation zones, right? So when you're doing the system design or looking at a system that's set up for partial evacuation, you want to make sure that a fire, on one floor, in this case, every single floor is its own evacuation zone. So a fire on one floor is not going to inhibit the operation of notification appliances on another floor. So that's why you typically see, your fire alarm system risers are in 2-hour circuits or in 2-hour, closets. Basically, that's as those circuits rise up through the building, that's ensuring that if there's a fire on the second floor, that's not going to impact the operation of the notification, all the way up on the 11th floor of the building. You're just protecting the system because it's a large building and it does partial evacuation. You want to make sure that, if something happens in one evacuation zone, it's not going to affect anything in another evacuation zone. So I kind of mentioned it before, but you can protect it with, 2-hour circuits, a CI cable. Carson will go over some of the details there, but oftentimes the equipment is also located in 2-hour closets. So you have electrical rooms that are rated for 2 hours. That's going to, house your amplifiers and your nodes. That's generally what we see, but there's also performance alternatives to this requirement that, may be approved by the AHJ. And, for new buildings, it's always best to comply with the prescriptive requirements. But for existing buildings, it's a little bit challenging. So that's why you often see, the AHJ, you can consult with them, during the system design and implementation. And if it's an existing building, it's a challenge to work with. There's usually an alternative that can be agreed upon. So the next topic here is the stair pressurization systems, like I mentioned before. So this requirement, different from the high rise, which was just out of NFPA 72. This is specifically required in the International Building Code, and that section's 909.20.6.1. Basically, it says, equipment, control wiring, power wiring, and ductwork all need to be, protected, either located exterior of the building within the stairway itself, that is pressurized, or if it's in the building, it has to be 2-hour protected. So what that means for the fire alarm system is that if the fire alarm system is controlling the stair pressurization system, basically, any wiring that is connecting, control modules to turn fans on or open dampers or close dampers, or, are essential for the operation of that smoke control panel in the fire command center or elsewhere in the building, that's all considered control wiring. And those circuits are required to comply with the 2-hour, protection requirement. So, again, if you have 2-hour rooms that you can run wiring in, you can use that to provide your protection. But oftentimes you have, 2-hour cable systems that are utilized to, provide that protection. Again, that's regarding the fire alarm system, but the same would be true if the building management system was controlling the stair pressurization system. It's basically any circuits that are, essential for controlling, the systems, the fans, the dampers, all that good stuff. Similarly, the requirements for an elevator pressurization system, as I mentioned before, are largely the same. Anything that's controlling that elevator pressurization system. So if the fire alarm system is doing that and you have a smoke control panel that has that elevator pressurization system on it, anything that's controlling that smoke control panel or, the fans and dampers associated with that elevator pressurization system, that's required to be, protected accordingly. And that's in section 909.21.4 of the building code. So those are some of the major systems and major applications where we see. There are a few others, and I mentioned those before kind of in the summary, but mass notification systems, like I said, that one's right out of NFPA 72. That's chapter 24, sections 365 and 366. That's all based on the risk analysis. So on a case-by-case system design is going to implement this risk analysis, and that's going to inform if the system needs survivability or not. If it is, then you're going to be required to put in protected circuits where deemed necessary. The other system that we talked about was two-way in-building communication systems. So that this would be the wired communication systems. Like firefighter telephones. I know those are being phased out, but they still are, out there. Those are going to require level 2 or level 3 survivability. If you're not doing firefighter telephones and you're doing your two-way radio, your bidirectional amplifier system or something similar, that's going to get kicked in. You're going to need required 2-hour circuits for that or 2-hour protection for that system as well. And then we go through the two-way communication systems for area of refuge, and then the two-way communication systems for just the elevator, elevator lobbies. NFPA 72 requires those to be level 2 or level 3 survivability as well. So those are 2-hour protection and or 2-hour circuits for those systems. And then, I think everybody will get a copy of this, but here's some, the NFPA 72 section references are all listed here for your future reference. So I'll stop sharing my screen here and kick it back over to Carson, and he'll go through some design examples and put some of the requirements that I talked about into real world applications.
Okay, Eric, can you see my screen?
Yep.
Okay. So Eric, in that first part, he covered what are the requirements for fire resistance rating of pathways and equipment, where do they come from and for what system. So now we're going to go over some design examples So the first one we will have is a high-rise building that has stair and elevator pressurization. So in this instance, the fire alarm system is performing the supervision and control of the smoke control equipment. So it's starting and stopping the fans, opening the dampers, supervising power, supervising fan status, supervising damper position. You have your main fire alarm control unit in a 1-hour fire command center, 1-hour rated, and the building has 2 remote networked fire alarm control units. Node 3 directly controls the smoke control equipment via dedicated SLC, and the smoke control fans themselves are located outside on the roof and ducted to the stair hoistway on the roof. So the protection requirements in this example would be we have a fire alarm system that's doing partial evac. So the fire alarm system itself basically needs to be 2-hour protected up until you have essentially, any circuit that is controlling evacuation from outside of the zone it originates from needs to be 2-hour protected. So from node 1 to node 2 and node 2 to node 3 need to be protected, because if you were to have a fire in, say, out here on the floor, this would take out the ability to evacuate other areas of the building or notify other areas of the building. In this instance, our example has a stacked 2-hour closet where, there's some obviously floors in between here. That's 2-hour rated construction. And then we have, the 1-hour fire rated command center. In between the command center and basically the bottom set of closets, we have fire resistance rated cabling. So that could be CIC, it could be MI cable, or you could install it in the concrete with 2 inches of concrete as well. And then you have the SLC that goes from node 3 out to the modules that are in a VFD room that control these fans. That needs to be also 2-hour protected. And this could be a class B circuit where you just have one pathway, or you could have a class A where it's redundant pathways. So that needs to be 2-hour protected. And then those modules that are controlling the VFD are in this room, and this room itself is 2-hour protected. So in this instance, you have a combination of listed cabling systems and fire resistance rated construction. And all of this, because this is a smoke control system, and this is something we'll talk about at the end, also needs to be in conduit. So it eliminates the possibility to do like free air CI cable or the armored option that's out there as well. And we'll get into that a little later. But in this instance, you can see, okay, the fire alarm control unit in the fire command center that's in the fire resistance rated construction as a non-rated connection between node 1 and the smoke control panel. And then my backbone, once I'm in this fire rated closet, the connection between node 2 and node 3 and everything in between does not need to be rated either, because again, I'm in this closet. It's important to note that the IBC requirement for stair pressurization protection is only the control circuit. So technically, it's really only the relay modules or control modules that are telling the fans to start and stop and telling dampers to open and close, and not necessarily the monitor modules that are supervising everything. However, those monitor modules, which are supervising power on the VFDs and current sensors for fan flow proof, those are typically all located in the same space. So it just makes sense to put all of those modules on the same SLC. And then it's important to note that once you're in this room, ideally this is just located below the roof line, so you can just go out onto the roof and you're outside of the building and you no longer need to be protected. But if you were to offset from this closet below the roof line somewhere else, where that routes below the roof line would need to be 2-hour protected until it got outside of the building. So this is our second design example. This is a high-rise building with partial evacuation. So Eric had mentioned this before. Again, we have the main fire alarm control unit and a 1-hour fire command center. And in this instance, this building has remote nodes, network FACUs, and each node handles 5 floors of evacuation. So this is kind of one section of the building where you have a node that goes 2 floors up and 2 floors down. So this is our backbone going from the fire command center. So this assumes the fire command center is not directly below our stack closet. So we need 2R rated cabling between basically the bottom of the closet when it gets to the first terminal cabinet and the main control unit. If this is going, if you're going to route a speaker circuit to one of the egress stairs, that's manual paging, that needs to be a 2-hour rated circuit because that's a dedicated zone. So you'd have that and that would go to the stair. And then once you're in the stair, you no longer need to be 2-hour protected. Again, same as before, where we have the backbone in a 2-hour rated construction closet. You can see all of this yellow wiring does not need to be rated. All of the branch wiring does not need to be rated because now I'm on the floor and serving the floor itself. But there's a couple one-offs we've provided here. So say you're doing a fit out in Boston or Cambridge where you come in, you're the installer, and there's not enough room inside the backbone closet that was originally there to put a power supply to handle an additional strobes on that floor. That power supply, as long as it's just doing strobes on that floor or the evacuation zone, that the control and monitor circuit from the backbone does not need to be rated. The power supply does not need to be rated, and the branch circuiting to the first device does not need to be rated. Alternatively, if you're doing a similar renovation and you have you want to put, say, a remote power supply on one floor, but for some reason want to take that remote power supply and feed a floor like 2 floors above, this now would need to be a rated circuit. You would need to rate this room, and your cabling to the first device would need to be 2-hour rated, and then from then on you would not need to be rated. Alternatively, if you had this closet here, and you were just doing a floor above, as long as these walls went full height, you don't need to really rate it because once you penetrate this floor, you're in the zone that you are feeding. And again, so that kind of covers everything. The notification appliances have to be 2-hour protected until they reach the zone that they serve. And in this instance, you're probably using MI or CIC cable. CIC because you're assuming this system's also doing smoke control. If you weren't doing any smoke control with any of this backbone, that would open up the opportunity for at least the backbone to be possibly the newer listed free air CI cable or the armored cable. You would definitely be able to do it for this cabling because none of this wiring would have anything to do with the smoke control system. So the last example that we'll provide is a high-rise building with a BDA. So in this example, the BDA, the bidirectional amplifier, is located at the top of the building. You have the coaxial cable backbone routed vertically down the building with splitters at each branch takeoff. And then they go out to each floor to omnidirectional repeaters on the floor. So NFPA 72, when referenced by the fire code or building code in the jurisdiction, has survivability requirements for BDA systems when they are provided in lieu of wired firefighter phones, and that's typically only in high rises. And basically you have to have, as we pointed out before, level 2 or level 3 survivability. So in this instance, you have a stacked fire rated closet or a closet here with a chase and access panels. Again, you're in the 2-hour rated construction, so none of this needs to be fire rated cabling because it's protected. Once you're out on the floor, a fire on this floor wouldn't take out the ability for the other floors to have coverage. You need to have, again, protection of this cabling, the donor antenna from the head end unit to here. So if it wasn't directly above and you were to somehow offset this horizontally on this floor, that would need to be 2-hour protected by one of the many options that's out there. And then again, the NFPA 72 requires annunciators for BDAs, dedicated annunciator panels, and typically that cabling is provided 2 hour between the head end unit and the fire command center. So you could technically have non-rated cabling up to a certain point, hit a terminal strip, transition to the rated cabling, and then go to the annunciator in the fire command center. Sometimes 2 hour protection is enforced in low-rise buildings in certain jurisdictions. But technically, if you read 72, it does say that the survivability requirements are only applicable when the system is provided in lieu of a wired communication system, which is not required in low-rise buildings, at least locally. It is important to note that once the 2016 NFPA 72 goes into effect in your jurisdiction, that the survivability requirements for BDA systems still reside in 72, but all of the design and installation requirements are now referenced to NFPA 1221. So now we'll get into some installation requirements and examples. So there's many different solutions and systems to meeting the survivability requirements of 72 and the fire resistance rating requirements of the smoke control chapters. Fire resistance rated construction's kind of the most popular, right? You're gonna have a closet or a shaft somewhere that's going to house your fire alarm system to begin with. So making it 2 hour rated with, fire rated doors is just going to eliminate the need to have fire rated cabling. That can now be standard cabling. 2 inches of concrete encasement. So you can take advantage of that in newer buildings. If you're doing an offset from a fire command center to your stacked closets, and it's a pretty long run. You could account for that in the design and plan ahead, and then you're burying it in the concrete, and you're not having to use CIC or MI cable. CIC cable is probably the one that I've seen the most popular when you do have you need rated system outside of fire resistance rated construction, and that's where you have a circuit integrity cable that's listed with EMT. So you have basically a fire rated cabling that's listed, a 2 hour listed assembly when installed, and we'll get into that in accordance with the listing of the product. So it's supported a very specific way. You're using certain manufacturers' tubing and so on and so forth. Endothermic wrap and EMT. So it's essentially another UL listed system where you take a conduit and you're wrapping it to give it a fire rating. This I've typically done this very rarely, but on BDA systems, because up until recently there wasn't 2 hour rated cabling, coaxial cabling available, although there now is at least, I think, one UL listed manufacturer out there. So that brings me into this next item. MI cable, that also is an acceptable one in lieu of CIC. When all of the CI cable lost their listings, I think this came into more prominence, but now that CIC regained its listing, very specifically, you have to use the specific EMT it was listed with. Now MI cable is starting to kind of go away, or at least I've seen it be less and less used on the fire alarm side. There is armored CI cable, so that's metal clad fire alarm cable that you could use if you're not doing a smoke control application. So if you're designing a building that has circuits that aren't related to smoke control, you could use that. Free air cable, you could do the same. So it's basically the same product, but it's not installed in EMT. If again you're doing something that has nothing to do with smoke control. And then last but not least, performance-based alternatives approved by the HJ. So say you were doing a fire alarm upgrade in an existing building and it wasn't feasible to get 2 hour rated construction or use a 2 hour rated system, you could take advantage of existing, say, 2 hour fire resistance rated separations and use those to separate your feed and return runs, with the idea being that if you had a fire on one side of that 2 hour barrier, that it's just going to impair that one leg and not travel over to where the other leg is and take that out, and you essentially have a 2 hour protected system through both that fire resistance rated barrier and the fact that you have a redundant pathway supply and return run. So some solutions that can kind of they're advantageous in what we'd recommend considering on the design and construction side. Getting 2-hour stack closets chases staffs, addresses the need for multiple 2-hour protection requirements. So in a high-rise building, in most of the buildings these days where the fire alarm system is doing the smoke control, you're going to have the 2-hour requirement for survivability. You're going to have the 2-hour protection requirement for the smoke control, and you're going to have the 2-hour protection requirement for the BDA. So by getting a 2-hour stacked closet, you can have your fire alarm backbone in there that is, the cabling and everything once you're in there is non-rated. You can also route a non-rated coaxial cabling system within there and have the splitters in there, and it essentially eliminates the need to have all of this 2-hour rated cabling or listed systems. And if you are dealing with new construction and it's pre-planned, it can really result in a significant cost savings. It's important to note that unless you had your fire command center directly under your stack closets, which is very rare, that the offsets from, say, the fire command center where that that head end unit is going to be located, and then you're going to have that BDA enunciator there. That cabling that goes from there to the stack closets needs to be 2-hour rated. So you could bury it in concrete. You could do a 2-hour rated system, such as CI cable and conduit. And do the same for the BDA enunciator cable. BDAs can be tricky because, say, you've accounted for that stack closet up the building, from grade and up, but then you go down and the lower levels are parking or something like that doesn't line up. Now you have to account for offsetting possibly your BDA coaxial cabling, and maybe using rated coaxial cabling or the endothermic wrap. And again, we talked about concrete encasement being an option for longer runs, if you're going from building to building, or if it's pre-planned again. It's important to note that if you are using MI cable, CI cable, or CI cable in conduit, there's very specific listing requirements that are specific to the actual product. So if you get a product by Radix or a Comtran product, there's a very specific UL listing that they've taken that product and they've fire tested it with certain EMT and certain attachment to structure. The spacing is very specific, and it has to be followed. So you need to make sure, if you're an installer, that when you're using this product, that you may not be able to use the EMT you've utilized on the rest of the project, if you're going by the specific listing. And you have to understand that it has to be supported. It's 2-hour rated. It's only as good as the structure it would be supported from. So it has to be supported from 2-hour structure, and the spacing, the intervals at which you support it are much tighter than standard EMT or free air cable. And again, this applies to any of these listed systems. The three most popular would be MI cable, CI cable, the armored CI cable and the free air, and then the CIC, the circuit integrity cable in conduit. And you not only have to follow the manufacturer's requirements, the UL listing requirements, but also the NEC. So the major takeaways from this presentation that we feel are kind of the most important to touch upon is, not, like Eric said, not all smoke control systems are required to have 2-hour protection. It's only stair and elevator pressurization. And then if you get into some jurisdictions that do have a floor-by-floor system, there may be some survivability requirements there. 2-hour fire resistance rated construction can negate the need to provide MI, CI, CIC cables. Like I said, once you're inside that 2-hour fire resistance rated construction, non-rated cabling can be utilized. A lot of times on projects, I'll see they have those rated closets, but then I see rated cabling inside the closet. And it's just one of those things that, I don't think it probably wasn't communicated to the installing contractor, but that's an instance where, that cost didn't need to be spent for that installation. MI, CI, talked about before, the specific listing in accordance with the NEC. Our recommendation, as engineers in the industry, and it is tough because, real estate on projects is always prime, and architects are always trying to squeeze us, obviously, but is to try to reserve dedicated 2-hour fire closets for fire alarm equipment and trying to avoid sharing those with electrical equipment, especially transformation equipment. While it's difficult to do with existing conditions, you do not need a lot of space for fire alarm equipment. And if you think about it, you put your fire alarm equipment in a 2-hour closet that also has electrical equipment. You've addressed the hazard of a fire outside of that closet from impairing that system up until the listing of the 2-hour separation, but you're still putting that fire alarm equipment in a closet that could pose a fire hazard to that equipment, especially transformation equipment. The risk isn't as high with, just switchboards and non-combustible conductors, but once you get into transformers, you're really not addressing the intent of the code, which is to basically have a system that can be survivable from any fire in the building, with the exception of obviously a fire resulting in the fire alarm system itself. So it's one of those things that was historically done. It continues to be done. But if you can get it, if you're an engineer, it's not a lot of space. And if you can get it ahead of time, it's really going to result in the most survivable system for the building. And then one other item to mention is, as Eric said, NFPA 72 does contain 2-hour protection requirements for wired communication systems, area of refuge and elevator, but those are not currently referenced by at least the base IBC. There could be local amendments that apply, or obviously designers are welcome to spec those compliance with those as good design practice. But as of right now in the model IBC codes, there's no references to those sections of NFPA 72. So some other items to consider, because I know we probably have some electrical contractors on the call today. It's important to note that the 2-hour requirements for stair and elevator pressurization also apply to normal and standby power. So, not only does, the fans standby power, which typically is, coming from the generator on the roof, but your normal power from the switchgear at the bottom of the building also needs to be 2-hour protected. You could do a similar design from fire alarm where you use MI cable to a certain point and you transition to non-rated cable. And then you go up and use your 2-hour rated, say, electrical closet, and you save on those costs, or you could just use MI cable all the way up. Another item to note, it's somewhat related to protection of the system, but all smoke control wiring, power and control wiring are associated with smoke control systems, regardless of voltage, is required to be in a continuous raceway. There's many different ways that section in the code can be interpreted and is interpreted across the country. I can say at least locally in like the greater Boston and Cambridge areas, that is commonly interpreted to apply to basically any cabling that is associated with the smoke control system itself. So that would be basically the control and supervision of the actual smoke control equipment, but not the detection and initiating side of like the fire alarm system that's providing input to it. If you're in jurisdictions such as California, they amend that section to be very clear that basically any high-rise fire alarm system that's doing smoke control, everything has to be in a raceway. Obviously, that has a significant cost impact on a project because there's no real, besides outside of the fire alarm and survivability world, there's nothing, at least locally, that says it has to be in conduit or everything could be free air. So it's something that's important to note locally. Again, that typically is just applying to the SLC, from the last node that's doing the control and supervision, and then the network cabling that's basically going from panel to panel. But that also applies to the electrical as well. So if you're doing a building that has operable doors or operable windows, you're not allowed to use MC cable for those power circuits. That has to be in conduit, and then you can use FMC obviously up to a certain point. Some inspectors limit the length to 7 feet or 10 feet. But it's an important thing to note is like anything smoke control having to do with power of the equipment or fire alarm or BAS interface to the equipment has to be in a continuous raceway. And then last but not least, it's important to know that there could be additional fire resistance rating requirements for electrical components that are in, the electrical code itself and amendments to the electrical code. So that's pretty much the conclusion of our presentation. We covered a lot. Would be happy to stick around if anybody had any questions. But that concludes our presentation.
It looks like Dan Finnegan had his hand up.
Yes, good afternoon, gentlemen. Eric, Carson, job very well done. I had one question, and it revolves on the fact that you did a great job of focusing in on the 2-hour rated pathway or the 2-hour rated shaft closet arrangements that are there. What do you feel when you come across one of those and it's got the rated room as far as construction, it's got a UL rated frame and door on it, but because the door is always kept locked because of its electrical room nature, there is no door closer on it. Are you still accepting that as a 2-hour rated assembly?
I think you'd still want to see a closer on it, especially because somebody could be working on that and a fire could occur and they may not think that, okay, I have to close this before I leave. So I think you'd still want to see the closer on that. I was recently out at a site where there was a small BDA closet that had a 2-hour door on it. And the inspector brought up that the building inspector brought up that door should have a closer on it. So I would say it's good design practice and to be an err on the side of caution to include closers on those doors for that exact reason.
Okay, yeah, we're just running into a lot of existing high-rise buildings that probably the nature of the building inspector group, everything is rated, listed, everything is all set, but they never put the closer on because they said the door is always locked. And they didn't, it wasn't a public pathway or anything of that nature. The public didn't have access to it. But I don't disagree with your word for caution, but at the same time, there's a lot of money to install a couple of 100 door closers.
Yeah, I mean, you can get the hinges that have the integral like springs in them. So I think there's maybe less costly options as opposed to the typical, door mounted closers. But yeah, no, it's a great question.
Thank you, sir. Keep up the great work, gentlemen. Thank you.
So Carson, Jerry Quinn here.
Yep.
So great job, by the way. I really appreciate the examples. And you mentioned in the retrofit situations, the engineered alternative solution to the 2-hour rated path and the supply and returns on opposite sides of a 2-hour rated wall. How do you see that being fairly readily adopted in retrofit applications, or what type of acceptance?
So I can tell you, I was working on a project in Boston, a large campus fire alarm upgrade that we were using fiber for the new network. And obviously there's not a rated, or it's been a couple of years, but I don't think there still is a rated option for the fiber. Mm-hmm. So this was a campus that had, many firewalls, both horizontally and vertically. And we designed and reviewed this with BFD and said we're going to have the supply pathway on one side of basically all of the supply and the return will always be separated by 2-hour rated construction, and that was acceptable to them. Now, that's not to say that sets a precedent, but you're essentially stating that here's an existing building that it's going to be difficult, or I'm using a technology that there's not a listed rated system available, and I'm going to meet the intent of the code, which is that if I have a fire in one zone of that building, that it's not going to take out my ability to evacuate or notify the rest of the system that's served by that. And that was accepted by the jurisdiction in that instance. I would say that you obviously have to prove a hardship. If you just go in there saying, well, we're trying to save costs, obviously that's not always well received. But I think if you have a good reason, especially working in existing conditions, the hardship is, all the ceilings aren't opened up and you don't have a clean slate to work with. But in that instance, if you can design for, one leg of the system to be, if you had a network riser and you had one leg of the system that's just remote from the closet, and it's just this 2-hour shaft down the building in a corner of the building, and your other cabling all the way up isn't always rated, you could say, at minimum, you're going to have those closets for the equipment be rated. But you could say, well, if the fire eats through that and it eats through the closet, or it eats through this offset where this is, I still have my return pathway that's in a 2-hour shaft on the other end of the building, and that's still going to make everything else function. So you can take advantage of those items. Most of the time the supply and the return go up and down in the same area. But if you're doing a project under like GSA, they require that the supply and return to be remotely located. So if you do that type of design and you carve out a small chase and you do, in the building where you can get it to work, and there's not going to be any, terminal cabinets or branch circuits coming out of that, it's literally a home run all the way down the building, then you could say, yeah, if I have a fire on this floor, all of this offset cabling will get eaten away. My equipment's still protected, but my other backbone, the return path, my backbone is on the other side of the building and it's 2-hour protected. So technically I didn't need that primary leg to be 2-hour protected.
Thanks. Appreciate the feedback.
Yep.
So I'm not seeing any other questions. Lots of folks saying great job and thank you. I think that's it for questions today.
Okay.
So with that, I'll just remind everyone that within the next day or two, this will be posted. So if you want to direct other people to be able to go and see the recorded presentation, they can feel free to go to AFAA New England and they'll find it there. So thanks again to Eric and Carson, and have a great day, everyone.
Thank you.
Thanks all.
Very well done, team. Good job.
Yes, nice job.
Thanks, Dan.